student. Myself Saurabh Kundu, Assistant Professor of Electrical Engineering Department, RERA. Now today I will discuss about a problem. That problem is clearly seen that there is a resistance 2 kilo ohm and a voltage source that is 20 volt, and another voltage source that is 30 volt, and another resistance which is connected in series that is 2 kilo ohm, and other side there is a voltage source that is 40 volt, and in between the two terminals, that is the load terminals A and B, a resistance is being connected. Here it is denoted as R out. So our problem is find out the value of R out. That resistance value should be calculated here, and also calculate the maximum power as well as in that circuit. That means actually to calculate the maximum power, that means actually this problem is the maximum power transfer theorem problem. And where maximum power transfer theorem problem, there should be a formula that is, we always know that that is a formula that P max, which is the maximum power, and P max equal to VTH square divided by 4 RL. That is the formula of the maximum power. That means P max, and it also needs some condition, that is Ri equal to Ra. Ra is the load resistance, and Ra is the internal resistance, and RL is the load resistance. But in that particular case, RL equal to RTH. So we can write the maximum power transfer theorem formula as P max equal to VTH square divided by 4 RTH or 4 RL. So the main formula is here need to be calculate the maximum power, and the formula which is being used, that is P max equal to VTH square divided by 4 RL or 4 RTH. So now proceed the problem. At first find the RTH. So according to Thevenin's theorem, we already know that all the voltage source can be replaced by its internal resistance if any. And here also consider the value of the internal resistance is 0. So this circuit again reconstructed for finding the value of the RTH as, just look at this 2 kilo ohm resistance and this 2 kilo ohm resistance, and this AB terminal, that means where R out resistance is being connected, this terminal is being open. And all the voltage source is being replaced by its internal resistance if any, and here consider the internal resistance is 0. So the circuit becomes 2 kilo ohm and 2 kilo ohm, these two resistance, and these two resistance, according to Thevenin's theorem, we can find the RTH we can find from the load terminal. So 2 kilo ohm and these two resistance are connected in parallel, so we can write RTH equal to 2 into 2 divided by 2 plus 2, that is equal to 1 ohm, and this 1 ohm, this RTH equal to actually R out. So we can write R out equal to RTH equal to 1 ohm. Okay. Now another problem in this part is that calculate the maximum power. When calculate the maximum power, the formula of the maximum power according to maximum power transfer theorem, the formula of the maximum power is P max equal to VTH square divided by 4 RL, where RL equal to RTH. Here we can calculate RTH already, but here we need to calculate VTH, that means this open circuit voltage VTH. So again we consider this particular circuit, and this particular circuit when we consider, then again this voltage source is being comes, and the circuit becomes this 2 ohm, this 20 volt and 30 volt, 2 ohm, 40 volt, all are connected, but this terminal is being open. This A and B terminal is being open, and we have to calculate VTH. VTH we have to calculate here for calculating the maximum power transfer. That is P max equal to VTH square divided by 4RL. So this VTH need to be calculated. So we consider this circuit as two loop. Two loop. So in the left hand side is the first loop, and here we consider that is a loop, and this according to KVL, this clearly seen that the current is flowing from that particular direction. So we can write 2 according to KVL, this 2 ohm resistance current flowing through I, so we can write minus 2I, and this according to direction, that is 20 volt source, so we can write minus 20, and again we have to consider 30 volt source, so we can write minus 30, and this 2 ohm resistance, so we can write minus 2I equal to 0. This is the total KVL. This is the total KVL formula according to the left hand side, but right hand side is being open, so no current flowing through it. So only we are calculate here. First we calculate the left hand side. So we can write minus 2I, minus 20, minus 30, minus 2I equal to 0, because according to KVL, in a loop, that is V1 plus V2 plus V3 is total equal to 0. So we can write minus 4I equal to 50 and I equal to minus 50 divided by 4. So the current becomes minus 12.5 ampere. So this current is being calculated. And again, consider the right hand side group. This right hand side group, when we consider and applying KVL, again we apply the KVL in the right hand group. So we can write this VTH, and according to direction, this VTH is positive. So we can write plus VTH plus 40 minus 30 minus 2 into current. This current, that means this I current flowing through the resistance 2 kilo ohm. So we can write minus 2 into minus 12.5 equal to 0. So we can write VTH equal to this 40 goes in the right hand side, so we can write minus 40 plus 30 minus a plus, but plus minus a minus, when this plus going in the right hand side, so we can write minus 25. So the answer becomes minus 35 volt. This is the VTH that is to be required while calculate the P max. Because P max is the maximum power, the formula of the maximum power is VTH square divided by 4RL. Here we calculate already VTH, that is minus 30 volt. So we can put this value in the formula, that is P equals to VTH square divided by 4RL equal to VTH, the value of the VTH is minus 35, so we can write minus 35 square divided by 4RL. RL equal to RTH, so we can write 4 into 1, that is 35 square divided by 4. The answer becomes 306.25 watt, which is the maximum power, transfer according to maximum power transfer theorem in this particular circuit. So the conclusion is, the main formula we have to use, that is P max, which is the maximum power, that P max equal to VTH square divided by 4RL. First we have to calculate VTH, or then we have to calculate RL, that is the load resistance, or load resistance RL equal to RTH, so we have to calculate RTH, that is the equivalent resistance. So our answer is 306.25 watt. Okay, that's all from my end.